Okay, so the steps that you will follow to make equations. That's step number one. Assalamu alaikum. So step number one is you will identify the reactants, right? Say quickly. You're going to identify reactants. Step number two. Step number two is you will write all possible electrode reactions involving your reactants. Involving only the reactants that you identified. And then you have step number three, which is so step number three, that's finally you've got step number three, that is the highest potential is the one that likes to gain electrons. Anode gains electrons. And the lowest one loses electrons. But it has to be one of your reactants that loses or gains electrons. So you have to ensure or watch out that ensure that one of the reactants that you've already identified you can't have any other thing gaining or losing electrons. It has to be one of the reactants that you've identified. Okay, so that's how you make equations. So we're gonna do more reactions, right? So for example, I have I said let's try simple reactions. So I've got bromine reacting with KCl, right? Now I already know that there's going to be a simple. No, there's not going to be any reaction in this. Just 1 second. Let me write a reaction where there's going to be a reaction. So let's say I've got Cl2 and it's reacting with KBr, aqueous. And Cl2 is a gas. So I need to figure out what's going to happen. So step number one, identify the reactants. So what are the reactants? The reactants are there's Cl2 gas, there is K+1 ions, and there is Br-1 ions. I'm going to just open the data booklet and I'm going to write down all electrode reactions involving these particular reactants. So Cl2, so I got one, which is over here. So that's 1.36, that's one. So I'm going to write down all possible electrode reactions. So that's one, Cl2. Who else? K+1. So go back. Do we have any other equation for Cl2? There's actually another equation for Cl2 as well. So we are going to use that one as well. Okay, that's another equation for Cl2. What else? K+1, right? So write down all possible electrode reactions. In reality, you don't have to write them because they'll be given or printed next to it. You can just mark it on that. So K+1, that's only this reaction. And then I have Br-1. So we're going to look for Br-1, which would be in B over here, which is, where's Br-1? I think it's that one. So that's 1.07 volts. So I've written down all possible reactions involving Cl2, involving K+1, and involving Br-1. So the last thing is the highest potential is the one that's going to gain electrons. So which is the highest potential in this? It's this one. This is my highest E naught. So this is the one that's going to gain electrons, right? So it's going to gain electrons, but I can't use this equation because it's HOCl that's gaining electrons. My reactants, I don't have HOCl over here. So I'm going to ignore this, or I'm just going to cut it out. But is this part clear that I'm not going to use this as my highest E naught? Is this clear? Yes or no? Is this clear? Jody, is this clear, Lena? Is that
Yes, sir.
so apart from that, if I remove that, who's the highest E naught? This is the highest E naught. That's the one that's going to gain electrons. And do I have Cl2? I've got Cl2. I mean, there is Cl2 over here. That is the one that gains electrons. So that's fine. There's nothing wrong with that. So this is out of the three over here, it is Cl2 that's the one that's going to gain electrons. And then who's going to lose electrons? The lowest potential. At the moment, the lowest potential is this one, minus 2.92. So that's the one that's going to lose electrons. But again, I don't have potassium. So potassium will not be able to lose electrons because my reactants don't have potassium. They've got potassium ions, but they don't have potassium. So I'm going to get rid of this equation because I don't have potassium. So that's not my lowest E naught. So if I remove that, my lowest E naught is this one. So that's the one that's going to lose electrons. Do I have Br-1? Yes, I've got Br-1. Br-1. I've got Br-1 over here, right? So I figured out K+1 is a spectator and Cl2 is the one that gains electrons and Br-1 is the one that loses electrons. So I have my two reactions now with me. And all I need to do now is I just need to select these equations. So I just need to select these equations, these two. So that's one. And that's my other one. So these are my two reactions. And I'm going to add them up. I'm going to write the overall equation. So my overall equation is going to be that I'm going to add up the reactants. The electrons gain and loss, they have to be equal, which they're already equal. So I'm going to add up the reactants. The reactants are Cl2. In the first one, in the second one, the reactant is this side. It's Br-1 that's turning into this. So it's 2Br-1. And I'm going to write the products now for both equations. So the products in the first one is 2Cl-1. And in the second one, the product is Br2. So 2Cl-1 is getting formed and Br2 is getting formed. And that's my overall equation that I'm going to get. Is this clear?
Yes, sir.
And this reaction is going to have an E naught cell, which is what reduction E naught minus the oxidation E naught. So it's who's getting reduced Cl? So that's 1.36. Who's getting oxidized? That's 1.07. And that gives me what? 0.29 volts. So that tells you how fast or feasible the reaction is. If you've got a positive voltage, that means the reaction is feasible. It's not a very high voltage. So that means the reaction might be kind of slow, but at least it's feasible. It's going to happen. The reaction is going to take place. Okay, is this clear? This one.
Sir.
Yes, sir.
So we can think of any two things and we can try and react them together. So let's say I've got let's say I've got FeCl2. Now I'm going to think of random things. I'm going to try and react them together. So I've got FeCl2 aqueous, and I want to react it with hydrogen peroxide acidified. So I want to figure out what's going to happen. At the moment, I have no idea what's going to happen. So identify the reactants. Well, there is Fe2 plus, there is Cl minus 1, and there's obviously H2O2, and there is H plus 1. I'm not going to think of H plus 1 as something separate. It's acidified, so that just means that these two would go together. So I'm going to the first thing I'm going to do is I'm going to try and write all possible electrode reactions that involve Fe2 plus. I'm just going to copy all of them, but just Fe2 plus. Anything that involves Fe2 plus, I'm going to copy it. So that's one, right? It had Fe2 plus in it. So that's a possible electrode reaction. So what else? Is there any other Fe2 plus equation? There's Fe2 plus over here as well. So let's just copy that. It has a potential of 0.77. So higher gains, lower losers, right? So right now we have no idea. All possible reactions involving Fe2 plus. So I guess that's it. Fe2 plus was over here. Fe2 plus was over here. Then Cl minus 1, you have. So I'm just going to pick this reaction because this one has Cl minus 1 reacting with OH ions. I don't have OH ions, so I'm not going to pick this reaction. So only your reactant. So I think it's the first one that I'm going to go with. Okay, that has Cl minus 1. Okay, ये clear है ना that I'm not going to pick this one. Cl minus 1 plus OH minus 1. My reactants don't have OH ions. So I've added this, and then there's H2O2 acidified. So do you see H2O2 anywhere? So there's H2O2 acidified. So I guess we can think of this reaction. That is 0.68. But acidified means, remember, acidified actually means that H2O2 has acid next to it. I think it's this one I'm going to go with. Because H2O2 acidified means that H2O2 plus there is H plus 1 ions as well. So I'm going to pick this one. So is this part clear that why I'm not picking this equation? Because it has H2O2, but it's not acidified. I mean, it's producing an acid, but like if it goes backward, then it will produce H plus 1 ions, but it is not acidified. Acidified means that there is H2O2 and then there is H plus 1 right next to it. Is this clear? You clear? Is this clear to everyone?
Yeah, yes, sir.
Okay.
Yes, sir.
So I guess that's it. I'm not going to pick this equation. This is not H2O2 acidified. And I guess that's it. So who's going to gain electrons? Who's going to lose electrons? The highest one is the one that's going to gain electrons, which is obviously the 1.771, right? That's the one that's going to gain electrons. And do I have reactants? I do have reactants. It's I do have H2O2 and H plus 1, right? So I guess this equation, there's nothing wrong with this equation. Everything is fine. So I'm going to go with this equation. That's my highest E naught. This is the one that gains electrons, right? Is that clear?
Yes, sir.
And then I have to look for the lowest E naught. The lowest one at the moment is the first one. That is the one that's going to lose electrons, but it's Fe that loses electrons. But I don't have Fe in my. There is no Fe in my reactants. I've got Fe2 plus. I don't have Fe. So I'm gonna get rid of this equation. So who's my lowest now? That's 0.77, right? So Fe2 plus loses electrons. I do have Fe2 plus, so I think this is perfectly fine. So we figured out which is the equation that uh loses electrons. Right? Is that clear?
Yes, sir.
Yes, sir.
And all you have to do is now you have to make the overall equation. You can just add them up, add the reactants, add the products in one step. The electrons have to be equal, so I'm going to multiply this equation by 2, right? You have to make the electrons lost and gain equal. And add up the reactants. The reactants in the first one is 2Fe2 plus. And in the second one, the reactant is H2O2 plus 2H plus 1. And you add up the products. In the first one, the product is what, 2Fe? 3 plus. And in the second one, the product is what, 2H2O? It's just 2H2O. That's it. And that's your overall reaction. You figured out what the reaction is. And you can calculate how fast the reaction is going to be, how feasible it's going to be, reduction E naught minus my oxidation E naught. What's the potential difference? So 1.77 minus 0.77. That's going to give me that's going to give me exactly 1 volt, right? So that's quite feasible, right? It means it's a positive voltage and it's a higher positive voltage. So that means the reaction would probably be very, very vigorous. Okay, so is this question clear?
Yes, sir.
Okay, Akshita, is this clear? Zohair, Ibrahim,
sir.
clear?
Yes, sir.
Yes, sir.
Okay. I said, remember, you're not the only time-consuming part is identifying the equation. But for you, the equations would be written like this. You just have to like do all the working over here. So it's going to be a lot faster. Okay. I'm just taking time copying the equations, right? You don't have to copy the equations, because they'll be right in front of you. You just have to mark them and work on the sheet that's given. I said, let's try and do another one. Let's say I've got a reaction between CrCl2 plus potassium dichromate 6 acidified. Okay, so when I write acid, there's got to be an acid next to dichromate 6. So this one. So identify the reactants. You got Cr2 plus, you got Cl minus 1. What's the reactant over here? It's K plus 1, and then there is Cr2O7 2. I mean, you should know what ions are there, right? And this one is acidified, so it's got H plus 1 next to it. So let's try and copy all electrode reactions involving Cr2 plus and all of these, right? So starting with Cr2 plus, where's I've got 2 reactions for Cr2 plus. There is Cr2 plus in equilibrium with Cr, so that's one possibility. Okay, that's one. There's another one where Cr2 plus is in equilibrium with Cr3 plus, so that's another possibility. It could also change into Cr3 plus, right? So that's another possibility, and so then Cl minus 1. Is there any other Cr2 plus? I don't think there's any other Cr2 plus. So then there's Cl minus 1. I'm going to take this one. And remember, I'm not going to take the other one, which is Cl minus 1 going with OH ions. Okay, so we can ignore that one. So then I have Cr2O7 2 minus acidified. So it's probably this one. So that's a possibility, and K plus 1, last one. So where's K? So this reaction over here. So remember, highest potential gains electrons, lowest is the one that's going to lose electrons. So highest is at the moment this one. This is the one that's going to gain electrons, but I'm going to reject this one. Why? Because it is Cl2 that gains electrons. I don't have Cl2 anywhere over here. So I'm not going to select this one. Who's the highest now? It's this one. This is the one that's going to gain electrons. And I do have Cr2O7. I do have H plus 1. So that means this is fine. There's nothing wrong with this one. This one is the one that's going to, this is the one that's going to gain electrons. And I'm going to try and figure out who's going to lose electrons. The lowest one is the one that's going to lose electrons. At the moment, the lowest one is, which one is the lowest one? That's minus 0.91. That's the lowest one. But I have no CR in my reactants. There's no CR over here. So get rid of this. Rejecting that, who's your lowest? I mean, the lowest was actually this one. But we're gonna reject this for the same reason, because we don't have potassium. So I'm going to get rid of this one as well. So who's my lowest now? The only equation left is this one, lowest one. And I do have Cr2 plus. That's one of my reactants. So that's the one that's going to lose electrons. And so I figured out what my two reactions are. Who's going to gain electrons? Who's going to lose electrons? They need to be balanced. The electrons have to be equal. So I'm going to multiply this one by 6. And I'm going to add up the reactants and the products. So the reactants are, in the first one, it's 6 Cr2 plus. And in the second one, the reactant is Cr2O7, 2 minus plus 14H plus 1. So those are my reactants from both equations. And what are my products from both equations? In the first one, it's 6 Cr3 plus. And the second one, it's 2 Cr3 plus 7H2O. So basically, this adds up to 8 Cr3 plus, right? And that's my equation, and that's my E0 cell is going to be higher potential minus lower potential. So it's 1.33 minus 0.41. And what do we get? क्या आ रहा है इसका? Anyone, Minail, Ibrahim, Zaina? What do we get for this?
Sir, it's 1.74.
Because this one is 1.74. So again, a very high potential, right? And so now, is this 100% clear? We're going to move towards more complicated cases, like very complicated cases. But is this clear?
Yes.
ठीक है. Akshita, is this clear? Zohair,
Yes, sir.
Jody,
Yes,
right?
sir.
Okay. So we're now going to move towards more complicated cases. So what happens is there's a thing called, I mean, not a chain. I mean, it isn't given a name. They don't call it anything, by the way. But sometimes what happens is, and this is specific to, I mean, these examples are specific to species that have multiple oxidation states. That have many oxidation states. Okay. So it's specific to that. So you've got elements. You can have a look. If you look at the pure table, not the about the if you look at the data booklet, you would notice that they are, I mean, look at Mn. Mn has too many reactions. It's got many possibilities. It's got many oxidation states, right? Even iron has a lot of oxidation states. So similarly, Mn has a lot of oxidation states. You've got other elements like even nitrogen has many oxidation states. You can have a look over here. Look at vanadium. Vanadium has a lot of oxidation states as well, right? Now, what happens is that there's going to be a thing called a chain reaction. What I mean by a chain reaction is that if you look over here, vanadium does not turn into vanadium 3+ in one step. It first turns into 2+, and then that 2+ is further oxidized to 3+. And if that 3+, if you want to further oxidize it to 4+, then it's going to be this reaction. So it's going to be like a chain reaction. If certain elements, if they want to get further oxidized, then the reaction will just continue on and on. So one example is like and I'm going to show you this by an example. So if I react tin with iodine and iodine is in excess, now these two are going to react with each other. So what are my reactants? The reactants are pretty easy. It's tin and iodine, right? So I've got where's tin? And it's just tin, right? So for tin, they have given us only one reaction, which is this one. That's it. Tin with 2+. That's the only one. And for iodine, we have only one reaction, which is I second. I is okay, this is iodine over here. So this particular case. So you've got tin and you've got iodine. Iodine is the higher potential, so it's pretty easy. This is the high E0, and that's your low E0, right? Tin is the one that loses electrons. Iodine is the one that gains electrons, and that's it. That's your reaction. Not very complicated. You write the overall reaction. Tin changes to, so the reactions are tin, and the other reactant is iodine, and the products that you have. What are your products? It's tin 2+ and 2I-1, right? And you can calculate the E0 cell, which is reduction potential minus oxidation potential. So it's 0.54 minus the other one, which is minus 0.14. So what do you get? 0.68? Is this clear?
Yes, sir.
Okay, so it's a simple reaction, higher gains, lower losers. Now, these are the products that you're getting, right? So what you're going to think now is that iodine is in excess. So you still have iodine excess present. So what you saw was that you saw that iodine oxidized tin to tin 2 plus. Now you're going to think of another reaction. Like after the first reaction has happened, right? What do you have in your solution? You have tin 2 plus that's formed. You've got 2i minus 1 that's got formed, and there is iodine that's excess. In excess. So that means there's obviously leftover iodine. Now you're going to try and think, will these things further react or not? So this is the first step that has happened. And now you're going to see if there's going to be a subsequent step after this. Will these species that are still present in the mixture, will they react further? So for iodine, it's going to be the same equation. There's only one reaction, so I'm just going to copy that. For tin 2 plus, I've got this reaction. And I have another reaction for tin 2 plus because tin 2 plus could change into tin 4 plus as well. So there's another reaction. So this could happen as well. Okay, that's a possibility as well. So remember, the first reaction is over. We're now trying to figure out what's going to happen after that. So the highest one gains electrons. So it's iodine that gains electrons. So that's the one that gains electrons, right? And there's nothing wrong with that. We have iodine because we had excess iodine, right? So that's fine. Iodine gains electrons, right? Who loses electrons? Well, this is the lowest. So tin should lose electrons, but I no longer have tin, right? My whatever I've left, there is no tin over here. So forget this equation. There is no tin. So it's never going to lose electrons. So this is my lowest now. So tin 2 plus is the one that's going to lose electrons. And we do have tin 2 plus. So it's iodine that's gaining electrons and tin 2 plus that's losing electrons. And we can construct another reaction. So I'm going to add up the reactants. My reactants are iodine and tin 2 plus in the other equation. And my products from both reactions are from the first one, it's 2i minus 1. And the second one, it's tin 4 plus. And the E naught cell for this reaction is, what is it? It's a 0.54 reduction minus 0.15. So we get what, 0.39 volts, right? Is that clear? Okay, so we get 0.39 volts. So I've got two reactions now. This was my first reaction. And this is a reaction that's happening after the first reaction had already happened. Right? So is this part clear?
Yes, sir.
Yes, sir.
Okay, so what has happened is that tin got oxidized to tin 2 plus, and then tin 2 plus further got oxidized to tin 4 plus, right? So the reaction did not stop after the first reaction. It actually continued. And you have to watch out for this, especially for elements or species that have multiple oxidation states. Okay. The easier way you could have spotted this is whether you were going to have redox or not. That iodine was 0.54, right? Iodine was the one that was, where's iodine? Yeah, what you could have done was you could have spotted it over here. That iodine was the higher potential, right? And that gains electrons, right? So it's going to continue to gain electrons as long as the other substance is the lower potential, right? So tin, it was reacting with tin, right? So tin, you can have a look with tin. That it was the lower potential, right? So it lost electrons. And it ended up forming tin 2 plus. But tin 2 plus was still the lower potential. So then it will further subsequently lose electrons once more, right? So there's a chain reaction that's happening over here. Iodine gains electrons, it's a higher potential. But tin will continue to lose electrons as long as it's the lower potential. So it will continue to get oxidized over and over again. It's going to turn tin 2 plus and it's going to further lose electrons and form tin 4 plus as well. And in this case, your overall reaction is basically the sum of the two reactions. So in this specific case, if this is reaction 1, and this over here is reaction, so the overall reaction will be, you add up the two reactions. And in the same way, you add up the reactants, you add up the products. So if I add up the reactants, it's going to be 10, then I2 in the first reaction, and in the second one, it's going to be again I2 plus 10 2 plus. And what are my products? My products are going to be, it's going to be 10 2 plus and 2i minus 1. And in the second one, it's 2i minus 1 and 10 4 plus, right? So you add up everything. The 2 plus will get cancelled out. It's on both sides. And I've got, so it's going to be 10 plus 2i2. And the product would be 10 4 plus. Plus 4i minus 1. Okay, so is this clear that this is a two-step reaction that you're having over here? Is this clear?
Yes, sir.
Yes, sir.
Okay. So remember, what you're going to do is, first reaction, figure out what's in your solution. Try and figure out, and you're only going to worry about those species that have multiple oxidation states. See if any of them further gets oxidized or reduced. So 10 2 plus did get further. So I'm giving you a homework. It's you can try this one, which is, try finding out this one. This is your homework. It's a similar question. Vanadium plus excess of Fe3 plus aqueous. So that's the question. That's your homework, TK. Try and find out whether they're going to react or not. Is that clear?
Yes, sir.
I'm just going to. Just 1 second, let me. But see, I've posted it there. You can post your solutions over here in the group. Okay, let's continue tomorrow then. Take care, everyone.
Allah Hafiz.
Thank you, sir.
Love Hafiz.